Welcome to this, part 2 of talking about functions. Remember that this right here notation, f of x, could indicate an equation, something like x squared plus 2, or plus 7. That's the same thing as saying y is equal to x squared plus 7. So really what we've got is this situation where y and f of x are acting like the same thing. That's a little simplistic, but f of x means the result of what happens when we plug in x. And that's worth mentioning. F of x means the result of what happens when we plug in x. So there's a special case, and today deals with several special cases. Here's a case of if I look back at the same f of x and I say f of 0, well, f of 0 would be 0 squared plus 7, or 7. This is like saying x was 0, what is y? And we have a name for that. This is also called the y-intercept. You know that from when we did lines. You know that whenever the y-intercept happens, that means x was 0. And that is one of the special cases. Okay, new problem. G of x is equal to 5x plus 1. What I'm first going to want you to do is find g of 0. And secondly, I want you to find g of x, let me rephrase, find x when g of x equals 0. Now, to understand what these directions are saying to do, the first one is saying to take 0 and to plug it in for x. So that gives us g of 0, actually I'm going to write this below, g of 0 equals 5 times 0 plus 1, which is just 1. X, when g of x equals 0, means instead of plugging in 0 for x, I am actually going to set the whole equation equal to x, or equal to 0. So what happens, sorry, I had to sneeze there. What happens is that we've got the whole equation equal to 0, so I'm going to get 0 is equal to 5x plus 1. Then I'm going to solve for x. So I subtract 1 from both sides, and I get negative 1 is equal to 5x, and then I divide both sides by 5, and I get x is equal to negative 1/5. So my two answers are this for the second part and this for the first part. It's worth noting that this first part was really a y-intercept. This second part is really called an x-intercept. But we have two different names for that. It could be an x-intercept, it could be a root, or it could be a 0. And that last name is what we're focusing on. That special name called a 0 is what we mean when we say a 0 of the function. So I'm going to give you a definition time. This is a definition I'm going to want you to know. Zeros of the function. They are all x values that make the entire function equal to 0. They are also called x-intercepts, and they are also called roots. And those three are synonymous. Zeros, x-intercepts, and roots all mean the same idea. So if up here this was example number 1, let's go back down and call this example number 2. H of x is equal to 2 minus x over 5. Same directions. Find h of 0, and for b, find x when h of x is equal to 0. So the first part means to actually substitute 0 in for x. So I get 2 minus 0 over 5, or 2/5. The second part is to set the left side equal to 0. Not to plug it in, but to rewrite it as 0 equals 2 minus x over 5. Well, all I have to do to get rid of 5 on both sides is multiply the right side and the left side by a 5. So I get 0 is equal to 2 minus x. And if I look at this, I can see that x would have to be 2. That's all there is to it. Sometimes we can do this from a graph. So I'm going to turn on the grid, and I'm going to graph the line y is equal to 1/2 x minus 3. Shouldn't be too hard. So y-intercept of -3. 1/2 would be up 1, right 2, and down 1, left 2. And I can get a pretty solid line going. Now you can see right here I have the intercepts of 6, 0 and 0, -3. Well, same directions. If instead of y equals, let's call that f of x. So I'm going to rewrite that as f of x. F of 0 is the y-intercept. That is this thing. So that's just equal to -3. And for part B, x, when f of x equals 0, that's just this thing. That's the x-intercept. Meaning it's kind of like something, 0. It means what do I have to plug in to get 0 out? And that is 6. And if I plug 6 in up here, I get 1/2 times 6 minus 3. In fact, I can write that, I should write that a little bit more formally. So I'm going to check it by saying f of 6 equals 1/2 times 6 minus 3, which is 0. And that's a little check that I get 0 out when I plug 6 in. I can do it on a sketch of a graph. So I'm not even going to do this. I'm going to turn the grid lines off. I'm going to draw a very loose graph. I'm just going to do this. And I'm going to say that this is the ordered pair -1, +5. And this is the ordered pair 6, -7. I know this isn't drawn to scale. And I could say that this graph represents g of x. Well, how would I find what g of 0 is? I'm first going to have to do something that I might not want to do, but I've got to. I'm going to take these 2 points, and I'm going to make a slope-intercept form of the equation of the line. So I'm going to do that by doing the slope. So let's set up my slope calculation. 5 minus -7 over -1 minus 6. That gives me 12 over -7. Then I'm going to do the point slope form. So y minus y1 equals slope times x minus x1. And if I kind of write that over here so I can keep this all on the same screen, I'm going to go y minus, let's use y minus 5. Let's turn this back into tablet mode. Y minus 5, and that's going to be equal to -12/7 times x minus a -1. So if I do y minus 5 is equal to -12/7 x minus 12/7, and then I add 5 to both sides, I'm going to get y equals -12/7 x plus. Then I have to add these two. Well, 12 sevenths plus 5 is the same as negative 12 sevenths plus 35 sevenths. So that gets plus 23 sevenths. So now I know that like my equation this capital G of x is equal to negative 12 sevenths x plus 23 sevenths. That's not very pretty. But notice what happens if I plug 0 in for x. I'm going to get 23 sevenths out. Negative 12 sevenths times 0 plus 23 sevenths is 23 sevenths. So that gets spit out. Now for part B, x when g of x equals 0 is a little bit harder. I'm going to say 0 is equal to negative 12 sevenths x plus 23 sevenths. I'm going to try to slide some of this stuff out of the way so I can have a little bit more space. That should be fine. And I don't like those 7s, so I'm going to multiply both sides by a 7. If I do that, I'm going to get 0 is equal to negative 12x plus 23. Subtract 23 over, divide by negative 12, and I would get x is 23 over 12, and that can't be simplified. And that's my answer. So I had to actually get the equation of the line. I couldn't just look at the graph. I had to use these points to get the equation of the line. So you can always get it from the equation. Okay. Lastly, just to kind of do a little bit of a review from yesterday, or the last lesson, I guess it wasn't yesterday for many of you. We had, let's say that I have f of x is equal to negative 1/2 x plus 2, and g of x is equal to 5x plus 7. We're going to do a couple of these little problems, and we'll call it a day. Let's say f of 1 plus g of 2. Then I want you to do 1/2 f of 3. Then I want you to do f of negative 1 times g of negative 2. So that dot in the middle is a times. And finally, we're going to do, let's just do g of negative 5 over 3. So this is just kind of pointing out some of the things you can do with functions. So I'm going to kind of stick some space in here so I have some space to work on these. On the first one, f of 1 means to plug 1 into the f function. So negative 1/2 times 1 plus 2. And then I could keep writing this out. This plus is this plus. And g of 2 means to take this 2 and plug it in there. So 5 times 2 plus 7. And then we just have to simplify that whole thing out. Negative 1/2 plus 2 plus 10 plus 7. So that is really, this is 19. 19 minus a half, which is, 19 is 38 halves, so this is 37 halves. Part B is to do 1/2 times f of 3. So this is 1/2 times negative 1/2 times 3 plus 2. I'm just literally plugging 3 in to f of x and simplifying this. 1/2 times, this is negative 3 halves plus 2. Or 1/2 times 1/2, negative 3 halves plus 2 is, well, I'll write that out. Oh, I didn't want to expand that. Let's get that back down. Okay. Let's see, 1/2 times, sorry, this is negative 3 halves plus 4 halves, or 1/2 times 1/2, which is 1/4. Let's see, for the next one, got f of negative 1, so that's negative 1/2 times negative 1 plus 2, times g of negative 2. That's 5 times negative 2 plus 7. So, let's get those down there a little bit. Negative 1/2 times 1/2, that's 1/2 plus 2. This is negative 10 plus 7. 1/2 plus 2 is 5 halves. 5 halves times negative 3 is negative 15 halves. And then finally, g of negative 5 over 3 is the same as 5 times negative 5 plus 7 over 3, which is negative 25 plus 7 over 3, oops, which is negative 18 over 3, or negative 6. And that's it.